Welcome to the Deep Dive. This is where we take your curiosity, look at the sources you send us, and really dig down to find what's truly fascinating.
And today, yeah, we're going way back using some really interesting scientific documents that you shared with us.
We are. Our goal today is to pull out the key details about this, well, remarkable creature from way back when.
Making sense of the science, without drowning you in jargon. That's the plan.
Exactly. We're talking about Andesaurus, the Andes lizard. That name alone kind of grounds you, doesn't it?
It does. It tells you where it's from.
Right. We're heading back to the Middle Cretaceous period, South America, specifically the Cenomanian stage.
Which is what, about 99.6 to 97 million years ago?
Roughly.
Yeah, around then. Think dinosaurs everywhere, a very different world. And we're focusing on this one key player. You told us you wanted to get the knowledge fast, but, properly.
And that's what we're going to do. Uncover some hopefully surprising facts and make them stick.
Okay, let's unpack this, starting with that name, Andesaurus. Yeah, it's, like you said, a direct link. Andes Mountains, where the fossils turned up, plus Sauros, Greek for lizard. Simple, but it works.
Named back in 91.
That's right, by Jorge Orlando Calvo and Jose Fernando Bonaparte. Big names in South American paleontology. Their work really opened up our understanding of dinosaurs from that region.
And there's a species name too, right? Andesaurus delgadoi, who was Delgado.
Yes, Alejandro Delgado. He was the one who actually found the fossils, so the species name honors him. Definitely deserves the credit for bringing this one to light.
A crucial discovery then. So what did he find? What are we actually looking at fossil-wise?
Well, it's a partial skeleton, not the whole thing, but, significant pieces.
Okay, like what?
Like 4 lower back vertebrae. Those are really important for understanding its back structure, how it held itself up, and a good chunk of the tail.
How much of the tail?
27 vertebrae in total, but found in 2 separate bits, so they weren't all, connected anymore.
And anything special about those tailbones?
Yeah, actually. The middle ones, the centra, that's the main body of the vertebra, they were noticeably elongated, kind of stretched out.
Elongated. Okay. Does that tell us anything? Why have long tailbones like that?
Well, it could suggest maybe more flexibility, or perhaps more power in that part of the tail, maybe for balance, could even be defense, though that's speculative. It's a feature we see sort of developing in later sauropods, too.
Interesting. What else was in the fossil find?
They also found parts of the pelvis, 2 ischia and a pubis bone, essential for figuring out its posture, how it moved, where those big leg muscles attached, and then some rib fragments and bits of the upper arm bone, the humerus, and the thigh bone, the femur.
Not complete limb bones then?
No, incomplete, but still really vital for estimating how big Andesaurus actually was.
Right. The big question. Size. How massive are we talking for this Andes lizard? Always helps to get a sense of scale.
Okay, so Andesaurus is generally considered a medium-sized sauropod, not one of the absolute giants.
Medium-sized meaning?
Estimates based on these bones put its total length somewhere between 15 and 18 meters.
So what's that in feet? 49 to 59 feet?
Yeah, around there.
Yeah, exactly. Think maybe 2, 3 large cars parked end to end.
Okay, that's substantial. And weight?
Estimated around 7 metric tons. That's about 7.7 short tons.
7 tons. Comparable to what, a modern African elephant?
Pretty much, yeah. A fully grown bull elephant is in that ballpark. So big animal, definitely.
Big, but maybe not the colossal scale we sometimes imagine for all sauropods. And I assume it had that classic look. Small head, long neck, long tail.
Oh, absolutely. That typical sauropod body plan. Small head, way up high on a long neck, big body, and then that long tail stretching out behind for counterbalance. It was a winning design for these large herbivores for a very long time.
Okay, standard sauropod shape. Now let's get into the nitty-gritty, the anatomy. You mentioned some unique things earlier. What really makes Andesaurus?
Andesaurus.
Right, this is where it gets interesting. One key thing is in the vertebrae, they have large lateral pluricles.
Pluricles. Those are the hollow spaces, the air pockets, right?
Exactly. Like internal cavities on the sides of the bones. For an animal this size, having bones that aren't completely solid, well, it makes a difference. Saves weight. Might have made it a bit more agile than if it was solid bone through and through.
Makes sense. Later construction. Anything else about the vertebrae?
Yeah, interestingly, it doesn't have a ventral keel that's a ridge along the bottom, which some related sauropods, like Fuingongosaurus, do have.
So different solutions to maybe spinal support or something, even in close relatives.
Seems like it. Also, there's a pneumatic feature, another airspace, but this time on the front part of the neural arch.
The neural arch, That's the bony bit on top, protecting the spinal cord.
That's the one, like a little archway over the spinal canal. Having air spaces there is pretty common in most neosauropods, the more, let's say, advanced sauropods.
Okay. Anything truly unique, maybe?
Well, there's potentially something, an extra ridge that seems to support the spot where the ribs attach lower down the parapophysis.
Potentially. Why only potentially?
Because of preservation, we can only clearly see it on one of the preserved vertebrae. So we need more fossils, really, to be sure if it's a consistent feature across the whole species or just, variation or damage on that one bone.
Ah, the frustrations of an incomplete fossil record. Okay, what about how the vertebrae actually connect to each other? Any clues there?
Yes, the hyposphene hypantrum articulations. Think of them as extra little joints that lock the vertebrae together, adding stability to the spine.
And Andesaurus had these.
It did, but what's fascinating is how developed they are. In really early primitive sauropods, these joints are large, making the spine quite rigid.
Okay.
But in some later titanosaurs, like Argentinosaurus or Apactosaurus, they're much smaller, almost just ridges. And in the most derived titanosaurs, they disappear completely.
So where does Andesaurus fit in?
It's right in the middle, basically. The articulations are smaller than in the primitive guys, but definitely more developed than in Argentinosaurus and those later ones.
So like a snapshot of evolution and progress. Moving towards more flexibility, perhaps.
It really looks that way. A transitional stage balancing support and flexibility as these animals got bigger and maybe moved differently.
Cool. What else?
Well, like other members of a group called Symphospondulae, which is part of the bigger Titanosauriforms group, it had these things called pre- and post-spinal laminae, basically ridges running along the neural spines.
The blade bits sticking up from the vertebrae.
Yep, those ones. And then if we look at the tail vertebrae again, they're slightly prochilous.
Prochilous. Okay, refresh my memory.
Think like a ball and socket joint, but maybe not as extreme. The front end of the vertebra is a bit concave, like a shallow socket, and the back end is a bit convex, like a rounded ball.
Okay, got it.
But in Andesaurus, this shape isn't as pronounced, not as ball and socket as you see in the really derived Titanosaurs. It's there, but subtly. Still, it's a diagnostic feature pointing towards that Titanosaur lineage.
So another hint of where its descendants were heading, evolutionarily speaking, towards maybe a more flexible tail.
Precisely. But it hadn't fully committed to that structure yet. Interestingly, the very first tail vertebra is a bit different flatter front, slightly convex back. Kind of like what you see in Episaurus.
Huh. Any other tail features?
Yeah, there's a noticeable depression, like a hollow, on the underside of some of the front tail bones. We see that in some other groups too, like diplodocids and some other titanosaurs. And the shape changes along the tail.
How so?
The vertebrae near the base of the tail are proportionally shorter, wider, but as you move towards the tip, they get longer relative to their width, almost twice as long.
That makes sense. Different mechanics needed along the tail, maybe. More power near the body, more whip-like further out.
That's a reasonable interpretation, yeah. We also see some lateral pluricles again, those air cavities, and small holes called lateral forima on some tail vertebrae. Their distribution across different sauropod groups is still a bit, well, poorly understood, phylogenetically speaking.
Always more to learn.
Always. And one last thing, like all titanosaur forms, the neural arch sits towards the front of the main vertebral body, the centrum. And the neural spines are tall, elongated, and kind of rectangular. That's a common blueprint in this wider group.
Okay, so it's this really fascinating mix. Some features look back to older ancestors, others point forward to later titanosaurs. This must make it super important for understanding titanosaur evolution, right?
Oh, absolutely critical. Several of these features are plesiomorphic, that means primitive, inherited from earlier ancestors without much change. And these features clearly mark Andesaurus as the most basal known member of Titanosauria.
The most basal, so like the earliest known branch on that part of the family tree.
Exactly. In fact, the whole definition of the group Titanosauria is anchored by Andesaurus. It's defined as the group containing Andesaurus, the later Saltosaurus, their last common ancestor, and all of their descendants.
Wow. So understanding Titanosauria starts with Andesaurus in a way. What's the key primitive feature that really sets it apart from later titanosaurs?
The big one is those tail vertebrae articulations we talked about. Andesaurus kept the amphiplation condition.
Amphiplaton, meaning flat on both ends.
Pretty much, yeah. Relatively flat ends, whereas most later titanosaurs developed those more pronounced procalyous ball and socket joints. That suggests the tail of Andesaurus was maybe less flexible, less whip-like than its later relatives. It's a clear link back to a more ancestral sauropod condition.
That's a major difference. Now, is there anything that's considered uniquely Andesaurus, a defining feature just for this genus?
Well, the one thing currently identified is the presence of quite tall neural spines on its back vertebrae, those upward projecting blades we
On
mentioned.
spines, okay.
But the original describers themselves noted that this needs more study. We need to understand how much variation there might have been and really confirm its significance. So it's a potential unique trait, but with a little asterisk next to it for now.
Right, another piece of the puzzle waiting for more evidence.
Mm.
Now, we talked about its size, elephant-sized, a couple of cars long. How does that compare to other titanosaurs? Was it
Right.
typical?
That's actually a really interesting point because some other early titanosaurs found nearby in Argentina, like the famous Argentinosaurus and Portosaurus, well, they were truly enormous, among the largest land animals ever.
So gigantism happened early in the titanosaur story.
It seems like it might have. But then you look at the latest, most derived titanosaurs, the Saltosauridae group, and some of them, like Saltosaurus itself, were surprisingly small for sauropods, relatively compact.
Huh. So it wasn't just a one-way street to getting bigger and bigger.
Apparently not. It suggests maybe gigantism evolved relatively early, but then later on, some lineages actually specialized towards smaller body sizes. It's a more complex picture than just bigger is always better.
Fascinating. You picture dinosaurs just getting inevitably larger over time, but clearly not always the case.
Okay, let's place Andesaurus in its world. Where exactly did these fossils come from, geologically speaking?
They were found in the Candelaros Formation. That's the oldest formation within what's called the Neuquén group, over in Neuquén Province, Argentina.
And the age again was Cenomanian stage, late Cretaceous. So around 99.6 to 97 million years ago.
Right. So if we could, hop in a time machine and visit the Candelaros Formation back then, what would it be like? What else lived there?
Oh, it's a fantastic snapshot of an ancient ecosystem. The Candelaros Formation has given us loads of fossils. Andesaurus wasn't alone?
Who were its neighbors?
Well, for starters, there were some pretty scary predators around, like the agile theropod Book raptor and the huge Giganotosaurus.
Giganotosaurus, one of the biggest meat eaters ever, right?
Yeah,
Sharing the landscape with Andesaurus.
absolutely. It must have been quite a sight. And there were other plant eaters, too, other sauropods like the Rabaxosaur Limosaurus.
So a really diverse community. Herbivores, big predators.
Exactly. It paints a picture of a dynamic, probably pretty dangerous, but thriving ecosystem that Andesaurus was a part of.
An ancient world full of giants. Okay, let's try and pull all this together. What are the main things we should take away from this deep dive on Andesaurus?
I think, firstly, it's really crucial position. It's our window into the base of the Titanosauria family tree, foundational. Its discovery in mid-Cretaceous South America tells us so much about the early days of this incredibly successful dinosaur group.
Right. Its importance for understanding the bigger picture.
Definitely. And then there's the creature itself, that unique mix of features. Some old inherited traits, like those flatter tail joints side by side with hints of the future, like the air pockets in the bones and the beginnings of procossless vertebrae. It shows evolution in action.
A transitional fossil in many ways.
You could certainly see it like that. And finally, putting it in its place, remembering it wasn't just bones, but a living animal in a specific environment in ancient Argentina, sharing its world with Giganotosaurus and others. That context is vital.
It really does make you think about the sheer scale of geological time, doesn't it? And how every fossil is just this tiny snapshot, a piece of an enormous, mostly lost story of life.
Absolutely. Which leads to a really interesting thought to leave you with. Given that Andesaurus so basal, so early in the Titanosaur story, what might the even earlier ancestors have looked like? The ones we haven't found yet?
Yeah. What led up to Andesaurus?
And what pressures, what environmental factors drove the evolution of this group into such diverse forms?
Yeah.
We had Andesaurus, and then these absolute giants like Argentinosaurus appearing relatively soon after, but also later, smaller, more specialized forms. Why such variety?
Good questions. It really highlights how much more there is to discover hidden in the rocks. A reminder that the story of life is always unfolding and we only have fragments.
Precisely. Endless mysteries still waiting?